right, welcome back. This is just part 2. I ran out of time on the first video, so I'm going to restart example 3 on this video. So to begin, we have a manufacturer is interested in the output voltage of a power supply used in a PC. Output voltage is assumed to be normally distributed, but standard deviation of 0.25 volt. What the manufacturer wishes to test is the null hypothesis. Again, remember this is the, this is the original claim that the mean of the population is 5 volts against our alternative claim being that the mean is not 5. And we're going to be using a sample size of 8 units. And we want to find the acceptance region is 4.85, less than or equal to the sample mean is less than or equal to 5.15. And we want to find alpha, find the value of alpha. So in order to do that, we are going to set up as alpha is equal to P, where the probability of that the X bar or the sample mean is less than or equal to 4.85 when the population mean mu equals 5 plus the probability of when the sample mean is greater than 5.15 when the population mean mu is 5. So in doing so, we're going to get P, where we're going to use our formula again of X bar minus 5 over 0.25 the square root of 8 is less than or equal to 4.85 minus 5. Right, because we're trying to find that X bar of 0.25 divided by the square root of 8 plus the probability that X bar minus 5 is 0.25 square root of 8 is greater than 5.15 minus 5 over 0.25 square root of 8. And in doing so, essentially what we're going to get once we find our z is that the z is going to be less than or equal to, let's go ahead and figure that out. So let's see, in this case, we are doing parentheses 4.85 minus 5 divided by 0.25, parentheses, 0.25 divided by the square root of 8. And you're going to correct me. There we go. All right. So let's see what we get here. Oh, wait. Oh, yeah. Sorry. It's supposed to go up here. There we go. So it'll be roughly 1.7 plus, since we are saying it is greater than, then we are going to want the 1 minus, because this is always going to give us the left probability, so we want the right since it's saying 1 greater than. So 1 minus P of whatever we just got. Okay, so in doing so, that's going to give me this value here of the 0.044 843. And then we want to do 1 minus that, which will give me the following. So we're going to have 0.04457 plus 1 minus 0.95543. All right, and in doing so, that'll get me, I'll draw it up here, 0.08914 to be our alpha. Okay. All right, now to do beta, I'm going to add another slide. And for beta, notes around. All right. So for beta, we're trying to find the power of the test for detecting a true mean output voltage of 5.1 volts. So define power. Power is defined as 1 minus beta. So for this, we're going to need to find beta, which is going to be very similar to what we just did for the probability of 4.85 is less than or equal to the mean less than or equal to 5.15 when the mean, in this case, we want 5.1 volts. So 5.1, and I'm going to just kind of click here. That way we get rid of that. All right. So in order to do so, we are going to get P, where we have 4.85 minus 5.1, because that is the population mean we are interested in. 0.25 divided by the square root of 8 is less than or equal to x bar, wherever it may be, over 0.25 square root of 8 less than or equal to 5.15 minus 5.1 over 0.25 square root of 8. Now, this is going to end up getting me P, and to calculate these, we can go through what I just made here. In this case, we're not doing 5, we're doing 5.1. So that will come out to, I'm just going to round to 3 decimal places, so that'll be negative 2.83. So negative 2.83 is less than or equal to Z, right? Because we're turning these into Z's. Or we're trying to find the Z-score. So then for this next one, I just got to change it to 5.15. Enter. All right, this is going to give me 0.566. So 0.566 is what we want. All right. Now I would like to take the probability, or draw arrow. Now I want to take the probability of Z is less than or equal to 0.566 minus the probability that Z is less than or equal to negative 2.83. The reason I want to do this is because I want to find the area between the two. All right, sorry. Let me go back. I want to find the area between the two, which is going to be my x bar. So I'm going to subtract the greater population mean over the sample mean by the smaller one. So let me get these probabilities. So these probabilities, in this case, is going to be 0.714196. So 0. And what I'm actually going to do, 0.566. There we go. Four. Three. I'll stop it there. Yeah, 1, 2, 3, 4, 5. I'll do one more. 3, 0. Yeah, I'll leave it there. Minus the other one. .83. All right, so that's going to give me 0.00233. So 0.00233. And then this is going to get me (7143) minus 0.00233. So that'll get me 0.71197. And remember, power is 1 minus beta, right? With this being beta. So then this will be my answer. All right, there you go.